Hello and welcome. My name is Matthias Beer. I'm a product manager for oscilloscopes, and I would like to show you today how to do pulse analysis with an oscilloscope. The oscilloscope I use today is our high performance oscilloscope RTP 084. And as signal source, I use a vector signal generator SMBV. And on the signal generator, I already set up a double pulse scenario which we here see on the oscilloscope display already. We see here the time domain signal, and I zoom into that, and we see that we most likely have a double pulse scenario here. But as we don't have a stable trigger, or we have some issues with the trigger, I use a small trick. I change the trigger type from edge to width trigger. I trigger on the negative pulse, and I'm say the range for the width is longer than 3 microseconds. Now, what does this do to my signal? I get a stable triggered signal, and we see here two pulses. One which is 2 microseconds, and one is 1 microsecond with a delay of again 1 microsecond. Now, the first thing what you usually would do is you would like to see the envelope of this signal. In order to get the envelope, we use our math editor. We go into the math function, we set up the editor, and for that I go to the advanced menu. I say I apply a low pass filter. I apply the low pass filter on my signal on channel 1, and as low pass filter frequency I simply use 50 megahertz for this example. So I type in 50 megahertz, and the type of filter I use is a Gaussian filter, and I can select here between a rectangular and a Gaussian filter type. I use the Gaussian. I close the brackets for the filtering, and in order to get the right amplitude, I have to multiply this formula with p divided by 2. So I enable my math function. I say 0 millivolt offset, then it is at the same level as my time domain signal, and we see here the math, the envelope, and in yellow the time domain. I can basically minimize my time domain signal, and we get still the envelope. Now we can use the envelope to do some measurements on the pulse. Typical measurements would be amplitude, the rise time, the pulse width, and so on. And in order to do this, you can use the predefined measurement functions which are coming with the RTP. And for that we have on our toolbar, we have different icons, and that's the icon for the automated measurements. And then once you press the icon on the toolbar, a window on the sidebar pops up where you can define different measurements. So you can find here the high value, the min max value, for example, the pulse width or the rise time. These are typical measurements you would like to see. You can enable the statistical values, and then you simply select the source you would like to use for this measurement. And then on the bottom here, you get all the measurements, the current measurement, but also statistical values. You see the min value, you see the max value, you see an average value of your pulse. Another thing when we talk about pulse analysis is the spectrum of this pulse. So you might be interested in how the spectrum of this pulse looks like. And in order to do this, we use another functionality. So I make my time domain signal visible again, and I apply our FFT functionality. I press the FFT button on the toolbar. On the sidebar, again, a menu pops up where I defined the frequency. So I use simply a 4 gigahertz center frequency, and I would like to do the spectrum analysis with a span of 100 megahertz. I select my signal source, channel 1, and I get the spectrum of my pulse. Now let me disable or minimize the measurement, and what we see here is the spectrum of the complete capture from the time domain signal. Now this is actually not what I was expecting. I was expecting some part which is related to the first pulse, and I was also expecting some frequency components from the second pulse. What we see here is a kind of overlay of the first pulse, of the second pulse, but also from the noise between the pulses. In order to make the information, the frequency information visible from the first and the second pulse, we can do a simple trick. We can apply another FFT. We use similar settings. So we use center frequency 4 GHz, a span of 100 MHz, and then I simply draw an area, a gate, where I want to apply my FFT. So now I have the information, the frequency domain information of the first part of the first pulse. And I can do the same thing for the second pulse. And now I have the complete spectrum of my pulse visible, but I also have the spectrum of the first pulse and the second pulse visible. And in order to do that, I use the gate functionality of our oscilloscope. So let me summarize what we have seen here. So we have seen a basic pulse analysis. We have shown how to make the envelope of a pulse, how to apply automated measurements like rise time, amplitude. We also get statistical values of our pulse. And at the same time, we were doing a spectrum analysis of the complete capture, but then we also did an additional spectrum analysis of the first pulse and on the second pulse to get a closer information, to get more information of my pulse. So this was our short video. I hope it was interesting for you, and I would like to say thank you for watching and goodbye. Bye-bye.